Today, we're going to take solving exponential equations to the next level by looking at these equations in context. So if we look at these formulas down here, they should look familiar from modeling exponential growth. And we would read a word problem and we would determine which equation we need to use, and we would use that equation. Now, the thing is, with those problems, we were always told the time. We were told that we invested $10,000 at 7% interest. How much will this investment be worth in 10 years? Now we're going to switch that, though. We'll say you have $10,000 and your interest rate is 7%. How long will it take you to earn for your account to grow to $30,000? So instead of trying to figure out how much money we would have after a certain amount of time, we are now going to figure out how much time it takes for your account or your item to be worth a certain amount of value. So what we should do is I'm just going to number these equations 1, 2, and 3. The reason for that is so that when we talk about determining which equation to use, we can just say, oh, we're going to use equation number 2 in this problem, and this is why. So these are the exponential growth models that we talked about. The first one, number 1, is just a regular growth model where something increases or decreases in value by a certain percentage every year. Equation number 2 is compounding interest, and that's when we had interest compounded quarterly, yearly, semi-annually, weekly, stuff like that. And then our equation number 3 was the one we used when we had our money compounded continuously. So you guys did a really good job using these formulas. Now we're going to use them to solve for time. So let's look at number 1. Erica and her husband bought a house that costs $160,000. They plan to keep the house until its value reaches $200,000. If the house increases in value at a rate of 9% per year, how many years will it take for them to reach their goal? So we have to first determine which equation we will use. We do not see the word compounded at all in this problem, so that means we're going to be using equation number 1. So now that we know we're going to use equation number 1, let's figure out what information we have. They bought the house and it was $160,000. So that's my p-value, my initial value. They want to sell the house when it's $200,000. So that's my a value. Like I was saying earlier, what we used to do is try to figure out what the a value would be after so many years. But now we're trying to figure out the t value, the years. And your rate is 9%, and as a decimal, that's 0.09. Okay, so our formula that we use was that, and we need to plug in our numbers. So 200,000 for A equals 160,000 times 1 plus 0.09 raised to the t power. So we need to get t by itself. So we'll divide both sides by 160,000. When we do that, 200,000 divided by 160,000 is 1.25, and that will equal 1 plus, this is a plus, 1 plus 0.09 is 1.09 raised to the t power. Now this looks like the equations we solved the other day. Yes, there's decimals involved, but we're going to go about this and use the same strategies. We're going to convert this to a log. Log. Our base is 1.09 of 1.25, and that's going to equal t. So then in my calculator, I'm going to do log 1.25 That looks terrible. Let me rewrite that. Log 1.25 divided by log 1.09. And when I type that in my calculator, that gives me t value of 2.59 years. So just because we have decimals, it does not mean you're doing something wrong. Most of these questions are going to have decimal answers. So you really need to be able to pick the information out from your word problem. So then on the next page, we see that we deposit $9,000 in a bank that pays 4% interest compounded continuously. In how many years will there be $15,000 in the account? Because it says compounded continuously, that means I'm going to use equation number 3 up here. And when we use equation number 3, the nice thing about that is that we can skip using the change of base formula because we have this e right here, e raised to some power. So let's look and get our information out. We started with $9,000, 4% interest is 0.04, and our A value is $15,000. We want to know how long will it take to get $15,000 in this account. So we're going to use A equals P times E raised to the RT power. And then we're going to plug in our information. So 15,000 equals 9,000 times E raised to the 0.04 times T power. So we need to get rid of the 9,000 in front. So we'll divide both sides by 9,000. And when I do 15,000 divided by 9,000, I get 1.67. And that equals E raised to the 0.04 T power. Now you may be saying, well, I have 0.04 T in my exponent. That's okay. Just like how the other day we had 3x in our exponent or x minus 6 in the exponent. That's fine. We just have to do an extra step later on. Now that I have e by itself, though, I can change this to log form. So log base e of 1.67 equals my whole exponent, 0.04 t. And like we talked about the other day, because it is log base e right here, we can change that to ln. And what that allows us to do is to get our answer quicker. We don't need to use the change of base formula because our calculators have that ln button, that natural log button. So ln 1.67, and I get 0.51. So 0.51 equals 0.04 t, and then I'll divide both sides by 0.04. And when I type that in the calculator, 12.75 equals t. So it will take 12.75 years for my account to reach $15,000. All right, then number 3 says you need $14,000 as a down payment for a new car. You deposit $10,000 in a high yield savings account that pays 8% compounded quarterly. In how many years will you have money you need to deposit? Then how many years will you have the money you need for the deposit on the new car? So because it says compounded quarterly, that means we're going to use formula number 2 up here. A equals this formula. So those things, that stuff in the parentheses is going to slow us down a little bit. But our p-value, our initial value is $10,000. We are aiming for $14,000. That's how much we need. And my rate is 8%, which is 0.08 as a decimal. And because it says compounded quarterly, my n value is 4. So now I can plug all those values into my equation here. 1 plus 0.08 divided by 4 raised to the t power. Now, what I'm going to do, is divide both sides by 10,000. When I divide both sides by 10,000, I get 1.4 equals, well, now I'm going to type this whole thing in the calculator. Just like that. So 1 plus 0.08 divided by 4. And I get 1.2. Oops, I forgot. This should be times nt. Which would make this 4 times t. So 1.4 equals, we got 1.02 raised to the 4t power. So now that I have my base by itself, I have 1.02 raised to the 4t power. I can change this to a log. Log with a base of 1.02 of 1.4, and that equals 4t. Now, when I use the change of base formula and do log 1.4 over log 1.02 equals 4t, when I type that into the calculator, I get 17. 17 equals 4t. And we divide both sides by 4, we get 4.25 equals t. So it'll take 4.25 years for my $10,000 investment to reach $14,000. So what I want you guys to do is I want you to try these last two. Remember to look and see which formula you're going to use, and then write down your information. So go ahead and try these. Once you're done, unpause this video and see if we get the same answer. All right, so here are the answers along with my work. Again, the hard thing about these problems is picking out the information from them. And then also, just being okay that you're going to have decimals in every step of your work. At the very beginning, we have a decimal from the interest rate, the R value. And then when we divide both sides, we get another decimal. And then we're going to have decimals within our logs. And that's why the other day we started with just regular numbers, so we could get the idea of, these are the things we have to do in order to solve these exponential equations, so that when we throw in decimals and throw in some real world applications, it's the same process. We just have different numbers here, and hopefully having a good understanding from the other day will help you with this stuff. So if you need to look at my work, I'll pause it so you can see this. But otherwise, thank you for watching. Make sure to like and subscribe.